Hello guys. Hi, myself Sumit. I'm a DevOps lead in video. I think it's an interesting topic to talk about because पैसे किसको नहीं बचाने चाहिए. Right. So yeah, let's talk about money. Okay. First of all, where I work. So I work in InVideo. We recently launched a new product which is called InVideo AI. What is InVideo AI? We just create video from a single prompt. I mean, the whole talk can be a video. I mean, if I just type one prompt, it will just give me the whole video. You can also check it out if you want ai.nvidia.io and just play around with them. So yeah, so as soon as we deploy, as soon as we launch the new product, the bees started facing multiple problems because we are dealing with AI workloads this time, and AI workload mostly uses GPU, and GPU are costly. So we don't know how to distinguish between individual workloads. And capacity planning is also a pain for us. And we were everything, I think for us, the whole monitoring system is in Grafana, and Grafana doesn't give us the dynamic clouds, basically, the real-time, real cost, what we are paying for them. And we also wanted to have alerts, like if the GPU cost spikes up on a daily basis, we get alerts as soon as possible. So what we tried, we tried multiple solution for this. We tried third-party tools as well, but we didn't get the solution what we wanted. So yeah, Kubecost is kind of I say blessing in disguise. It came for us, and why? Because it has four most important features which kind of solve all our problems. Basically it has the cost allocation, so where you get the efficiency part, whether your cluster is efficient or not, or whether the whatever resource and memory you have allocated to your workloads, whether it is properly utilizing it or not. And also it has cloud billing integration, so that's basically if you have a saving plans or any kind of RI or spot uses commitment, so it kind of calculates the cost based on that. It also have recommendation, I think, which is one of the best features, which in my opinion, because it clearly tell like where you can save the cost based on your cut down of the CPU RAM, and if something is unused, you can simply get it from there. Also have it's a good alert system in my opinion. Yeah. So how we started the Kubecost is basically we categorize our workload in multiple namespace. Like we are sometimes some are compute intensive, some are memory intensive, and some are GPU based. So we don't know earlier that when the cost spikes, we don't know which services are actually consuming the most cost, like which service is burning the more cost for us. So we kind of categorize into that, and after that we kind of observe the whole thing for a week, and we tune the workload based on the efficiency which we saw on the Kubecost. We kind of keep doing it and we follow the trend basically of the cluster for a week. And based on that, we allocated the budgets and alerts for each namespace and teams as well. Yeah, we have multiple teams, so basically each has a specific budget, so you guys can also allocate a budget and basically add alerts on top of that. I'll just quickly summarize this part as well. So basically, it also provides asset monitoring for us, like if you have unused PVC in your system, and if how much disk you are using, how much GPU you are using, how much computer you are using. So it also gave a quite insight based on that. We can also add alerts on GPU cost based on it, because these are expensive. And yeah, I was talking about the insights earlier. So basically, these size your nodes, pods, and local disk and PVCs. You can delete and assign resources if you want, like obviously you want. Yeah, reserve instance, pod instance recommendation also it gives. And it also has a good health dashboard that will give you whether your clusters are healthy or not. So yeah, you can see some of the snippet I added of our test cluster, where you can see like how much dollars we are paying, how much we can save, what's the efficiency, and this is a health dashboard I was talking about earlier. And this is the efficiency graph you can see, and how much we allocated. And this is the last one is how much per namespace you're consuming basically. So overall, yeah, after using the Kubecost, we kind of save the 30% cost on the EKS, and I think they're quite learning for us. Like first of all, like let's not when we see that our cluster is only using 50% of ours, like 50% efficient. So let's not simply go and reduce the CPU memory or whatever resources you are using, because sometimes it also depends on the workloads. We see that most of the service uses GPU, but on their side the CPU is mostly ideal there. So because also AWS doesn't provide instance where we have at least minimum CPU and at least one GPU. So based on that, it also gave us a false value sometime. So yeah, that we can think of basically. Also, we can establish a clear owner for that, and we can review our data on a consistent basis. And they also launched a predictive cost metrics. So based on that, you can see before deployment how much cost is going to be there. Uh, Conclusion, yes, we love Grafana monitoring, but I believe that Kubecost gave us a better monitoring as per Prometheus. And yeah, it also have good amount of CPU and GPU memory users. So yeah, thanks. That's for my time. Thank you guys.